Foundations of Amateur Radio. The other day I received an email from a fellow amateur, Elwood, Whiskey Bravo 0, Oscar Echo Whiskey. We've been exchanging email for a little while, and having been in the hobby since before I learnt to ride a bicycle, he's always got some interesting insight into something I've said and an encouraging word to share. This time he introduced me to a project he built and published a couple of years ago. It's a variable frequency standard built from parts and at the time costing all of about $150. More on that shortly. Compared to the microwave oven-sized HP 606A signal generator sitting on my bench in bits, with some diligent layout, this project could fit inside one of the valves that drives this massive hunk of equipment. As an aside, truth be told, I'm a little afraid of the HP. It managed to pop the RCD, a residual current device or safety switch, in my house, and in doing so took out the UPS that powers my main workstation. So, not unexpectedly, I'm reluctant to repeat the experience. Once I understand precisely what happened, I'll pick up the restoration efforts, and based on what I learned today, it might get me where I want to go faster. Elwood's Frequency Standard is a very interesting project that delivers a very precise variable frequency oscillator, or VFO, with an accuracy approaching 1 part per billion. His project uses an Arduino to control a touch-sensitive display, read a knob, and set and correct the frequency, using a GPS as an accurate external time source. It's all very compact, easy to follow, and I immediately thought that this would be an excellent project to build with a little twist. I'm thinking that it would be really great to have this device sit on your local network and make it remote controllable. The heart of this frequency standard project is a chip called an SI5351. The Silicon Labs SI5351, to use its full name, was first sold by Mouser in 2010 and has been popular since. You'll find it in all manner of places, including the Linux kernel source tree, the QRP Labs QCX and BitX, to name two, the Elecraft KX2, scores of Arduino projects, and countless frequency source products and projects used in amateur radio. The SI5351 is a configurable clock generator. Think of it as a programmable crystal that can be configured on the fly as often as you like. For configuration, it uses an I2C bus, or Integrated Circuit Communications Protocol, a special serial bus intended for chip-to-chip communications, invented by Philips Semiconductors in 1982. That's the same Philips from the light bulbs and audiocassettes, CD, DVD and Blu-ray, also the Philly shave. To complete the picture, Philips Semiconductors became NXP in September 2006. Back to our frequency standard project. I wondered if I could cut out the Arduino from the actual correction process, since I didn't need a display or a knob, and discovered that the SI5351 comes in several flavors. Elwood's design uses the A version, but there's also a C version that has the ability to take in an external clock, like say that from a GPS, and correct within the chip itself. With that information in hand, I figured that I could use a simple Wi-Fi capable system on a chip, something like, say, an ESP8266, to configure the clock and take care of communications with the outside world. In the process, I'd learn how to do a bunch of new things, including my first foray into generating RF, first time writing actual firmware, first time designing circuits, and no doubt many more firsts. Then I hit a snag. It seems that the SI5351 has gone from commonplace to zero in stock. Not just zero in stock in Australia or the US, no, zero in stock anywhere. There are a few A-version breakout boards, that is, the chip on a circuit board, available from one supplier. There's also a new compatible chip, an MS5351M, available from China, but that's a drop-in for the A version, not the C version. So where it stands is that I can almost taste the design, essentially 3 chips, an almost trivial circuit board, some SMA connectors, a power source, and an external GPS antenna, something that would represent the very first circuit I actually designed, which is a long way from reading the circuit diagram for my Commodore VIC-20 back in the days before I owned a soldering iron. It did bring me face to face with an odd realization. There are components that we use in day-to-day use, ones that are common, used across many different industries, that come from a single source. I should also mention that this particular manufacturer just got sold to another company, which doesn't help matters. Nobody seems to know how long this shortage might last, with forecasts varying wildly, but I'm beginning to wonder how many of these kinds of components exist, and how we might reduce our dependence on single-supplier hardware. I'm also starting to look at using an FPGA to do all of this in software, but that's going to take some time. Of course, we could start using valves again. My 1960s-era HB signal generator is starting to look much less intimidating. I'm Ono, Victor Kilo 6 Foxtrot Lima Alpha Bravo.